Hi class, welcome again to another session on biomaterials. So we have discussed all the topics in our soft tissue replacement implants. So let us move on to hard tissue replacement implants. So there are numerous devices that are used to fixate bones and hard tissues. So when I say hard tissues, I mean structures such as the tendons, the ligaments, along with the bones, right? So hard tissue implants can be of the following types. It can be a bone screw, bone plate, bone wire, or it can be a joint replacement implant such as the hip implant, knee implant, ankle joint implant. Then you have the shoulder replacement implants and the bone salvage implants. So let us have a look at these implants one by one. So starting off with bone wires, so these are fragment of these are like tiny wires that are used to connect fragments of bone that are either detached from a broken bone or that are either detached from their parent surface due to a surgery, or they are broken due to a trauma. So, an example for such a fixation is trochanter after hip replacement surgery. So that is trochanter is fixated using bone wires. Now, you also have like bone wires are also used to provide additional stability during a surgery. Suppose it is a spiral or oblique fracture of a long bone, right? Or that needs to be stabilized by other means, then bone wires are also used along with implants such as the plates to say stabilize the bone. So they've also been used to stabilize the lower cervical spine and the lumbar segments. So if you have issues with your vertebral column, then bone wires are used. It is hard to put a wire in your a rod or something in your spinal cord, right? Because it's quite flexible. Now bone wires, like the name suggests, it is used to tie two bones together. So if you want to tie something, you have to knot it, right? So wires, if they are subjected to twisting and knotting, then their strength reduces by up to 25%. So there are chances of the wire fracturing or implant failure, right? So this can partially be reduced by using a slightly thicker wire. However, you can't exorbitantly increase the thickness because you have a tiny piece of fragment that needs to be punctured, and this wire has to be inserted in it, right? So you can't just use an infinitely thick wire to avoid fracture. So there's only a certain amount of thickness that you can compromise upon, but that this is like temporary solution. Wiring fracturing of a bone wire cannot be avoided because of twisting and knotting, right? So the deformation region also, if there are indents, like while twisting the wire will definitely have indents in it, right? It's not going to be a smooth flexing of the wire, because when you are twisting it, the wire will have sharp edges. So these edges, they are more susceptible to corrosion when compared to the smoother surface of the wire. So in order to reduce corrosion and facilitate easy handling, these bone wires are annealed. The annealing is a process that metals undergo. Also, in order to have a more efficient bone wiring, multi-braided wires, instead of having a single monofilament of wire, it is braided wires are used, so which are stronger compared to say, a monofilament wire of the same diameter. However, one of the major disadvantages, while you're braiding, there are gaps between the two wires, and bone growth can occur in those gaps or in those striations, right? So, or grooves as they are called. So, if bone growth occurs in the grooves of the wire, it is very hard to remove this wire. So, only if it is a permanent implant, it is not going to be removed at all. Multi-strain wires are not used for bone implant as bone wires. Moving on to bone pins. So the most popular one are Steinman and Kirschner wires. They are Kirschner wire, although it's called as wire, it's a bone pin. So these are used to hold fragments of bone together. either provisionally or permanently, and they assist in guiding large screws during insertion. So it is, since it is pin, it is rigid, right? So if you want to mark the area where you need to insert a screw, you just mark it using a pin, and then you use that hole to puncture, you pierce and insert the bone screw. So the holding power of the pin is dependent upon the elastic deformation of the surrounding tissue. So if the surrounding bone is fragile, then the holding power of the pin is not going to be very, very high. If the bone is healthy and if the bone has got good elastic deformation, then the holding power of the pin is superior. So threaded pins are also used to hold to increase the holding power, because there will be grooves in the pin, right? So that would help anchoring the pin much more strongly into the bone. So most of these pins are made up of 316L stainless steel, and also pins are made up of PLA and PGA. PLA is polylactic acid and PGA is polyglycolic acid. So these pins made up of PLA and PGA are biodegradable and are usually used to treat minimally loaded fractures. So the fractures where there is not much of loading occurring, so these pins are used there. So pins are also a part of an elaborate frame designed for external fracture fixation. So if there is a larger fracture, instead of bone wires, you can also use bone pin to set the bone into a particular frame, and then use other fixation methods to make sure that the bone stays there permanently. Now the applications of several pin above and below the fracture fragment is done in order to fixate the bone, and these fracture fragments are manually augmented to resemble an intact bone. So this usually is done in fractures where the bone is broken into many fragments. Suppose there's an accident based trauma and something heavy falls on the bone, then the bone fractures into multiple fragments, tiny fragments. So in that case, putting all the bone pieces together, it will be like a jigsaw puzzle, right? So you want something to hold the jigsaw together, and in this case you use the bone pins to hold those pieces of fragments together, and then use another fixation device, say either the rod or the plate, and then make sure that all the fragments stay in place, and the bone starts healing. So this is a figure where you have two types of bone pin tips. So there's a trocar tip and the diamond tip. So these have different applications, basically depending upon the kind of bone and the kind of insertion you need. Either of these pins can be chosen. Trocar pins are widely used. I hope you had a fruitful session learning about bone pins and bone wires with me. I shall see you again in another video where we shall discuss more of bone screws and bone plates. Take care till then.